Hello and welcome. Today we will be exploring the SAS Enterprise Miner to showcase some modeling techniques on tree neural networks and clustering, and we'll be exploring some few little concepts on that. So first of all, first we need to create a project and create a diagram that I've already created here by the name of adult data, and you can first start by importing the file that I've done from the sample file import tab. And once you import the file, you can go to the Start Explore tab, and basically uh, once you go to the Start Explore tab, you can set the rules and what all variables you want, and the interval distribution, how do you want the distribution to be? Should it be chi-square distribution? And once you've set all those properties, you can right click on that and click on Run. So once you click on Run, the Start Explore tab will run, and it'll show you the chi-square plot, and the split will be based into 5 bins that is already stated here, and uses a chi-square value to judge whether the statistic was useful or not. The results are here. Let's see what the result states of the chi-square plot, that and the columns. The chi-square plot basically tells you the columns that will be useful in the summary statistics. So here are the few columns that were there in our data set, called the relationship, marital status, education, so on and so forth. You can see the output tab here and see the standard deviation also here. So since the standard deviation is a lot here, we'll be studying that in the impute tab later on. So next you go to the data partitioning tab, where you partition the data into the training and the validation data, and then you go to the replacement tabs, where you set the class variables and the interval variables depending on how your data set is set. Then you go to the control point. This is basically a read friendly format, and the control point is inserted. You can see control point is here also and here also. Here we are using the control point to divide the model into three. Here we are using the control point to take all the models and computing it for the model comparison. So now we'll be studying the decision tree and the interactive decision tree, for which basically we'll click on the decision tree and see the properties that we have set for the node size, that is the leaf size we have set to 8, and the number of surrogate rules that we have set to 4. So what basically is happening in the number of leaf size is that it is allowing us to select how many maximum training observations that we need for pruning, that is 8, and the depth is 10, that is the number of generation, plus the surrogate rules relies on the important concept that states that splitting value is an important value that should be kept into mind. So that is one concept that can be taken away from that, is the pruning size. If we do not prune our tree, it's probable that we can achieve 100% accuracy on the training data set, but we will not be able to achieve on the test and the validation data set. So we right click on this and we run the model, and let's see how the decision tree comes out to be. Interactive decision tree is also similar to decision tree. It's just that we get one node, and from that we can devise our split methods and see how it works for us. So first, let's see the results for the decision tree, and then we can explain the interactive decision tree. See, the decision tree has come up here, and it's dividing the node into relationship at first, and then it is basically taking different variables like husband. So it is taking the missing data also into consideration here. So which is why the importance of surrogate rules come into play, and then we have capital gain and capital loss as one of the parameters to decide which how the split is going to occur. Next, uh, we will go to the impute. The interactive decision tree is much more the same. Let's run it and see. We have set our cluster and the neural networks also here. So clustering has nothing important, nothing much deep as per the execution. It's just importing the file and clustering based on that. and neural network has transformations within it. So what we did here was I was seeing the log transforms, and I saw that the relationship was the most important criteria for the split rules. So if you want to edit it, so edit and graph properties, and you can edit the nodes here and see how it's going to be. Like you select the node, edit, file, view, and you can select all the settings that you want here. You can add more nodes and see how the split goes. Then you go to the imputing function. Now see that in decision tree and interactive decision tree we use the surrogate rules, but for neural networks you need to impute the data and transform it, since there is a problem that the missing values might be ignored in the neural networks, and neural networks we have to use these imputations and transformations to basically transform the logarithmic values, and see we are using the properties of interval imputes and class imputes to determine how the imputation needs to be carried out. Then we do the variable selection based off on the R square method and the number of bins allocated. So we can select all these properties based off on that, and we can check the results once it's. We can click on the formulas tab in the neural networks to see the histograms for different variations. This will show us the data is skewed and the log transformations to control the skewness. And that is one important feature, that if the data is skewed, you'll probably not get the best of the models. So then you need to put log transforms for that case. So here you see the train and the validation data cumulative lift for the neural networks. Next, we have done the clustering. It has we just added the cluster model from the SS tab, and then we added a control point to see which model is the best. Here is the file import for the test dataset that I've already imported, and we are scoring the model. So once the score is done, it shows us the results. You have to add the model comparison tab that I missed out here. Basically, to compare this tab will help us to compare which model is the best. And when we score the model, I'll show you in the output that we'll be getting an accuracy based off on that. So we'll see the results here. You can see that the accuracy for the classification was 82.3654% for the target salary, and while for the segmentation technique we got an accuracy of a little lesser value, 82.3654 and 82.3263. So we see that the accuracy values differ for different algorithms, and we need to wisely select it while computing our best model. That is it for today. Thank you.